Hello, welcome to the Signalling Guy. Now, big news this week. Train passengers lost nearly 1 million minutes in delay because of signal failures in the last 5 years. So this was announced yesterday. So, signals being broken has caused 1 million minutes delay in the past 5 years. So that's 200,000 a year. Just about. Now here's the thing for you that you might not know. Signals very rarely go wrong. No, okay, maybe not very rarely, but it's quite uncommon. What is much more common to find that's your track. That's a signal. Believe it or not, I used to draw for a living, sometimes by hand. People actually paid me to draw by hand. Anyway, in our track, we have a circuit. We call it a track circuit. Now there's current running through the rails, and we divide the tracks up into little sections. And into one end, we feed in current onto the rails. We actually do it with two cables to do the same job in case one of the cables breaks, and then it still works. Okay, so we have thought about this, signalling guys and gals. We are actually thinking ahead about what might go wrong. Okay, so you feed in at one end, and you come off at the other end. Into a thing called a relay. Now, I'll just draw this as a load for now. So if you're familiar with proper electrical diagrams, this is supposed to represent a load, okay? And you take another cable from the other side of the relay, feed that into the tracks. There's two of every cable so it doesn't go wrong. And at the opposite end, that we go back to your power supply, and that gives you a complete circuit that's through the rails. Now, ideally, when your train wheels come along, so these parts of the rail are insulated from each other, and when your train wheels come onto your track circuit, they short it out, and there's no supply to your relay anymore. Now, when this signal wants to be, let's say, green, just for simplicity, the signalling system, however it's whatever type of technology we're using, the signalling system, when it wants this signal to be green, will check the track circuits ahead to make sure that none of them, in theory, have a set of train wheels across them, any sets of train wheels across them. And only if your track circuits are a complete circuit, that is nothing on the rails and none of the cables, or at no point two of the same cable broken, and also the relay working, and also that feeding back from here to the signal box, because it doesn't happen. The checking ahead doesn't happen at the track side. It actually happens somewhere a bit more remote. So as long as all of that's working, then if I want this signal to be green and the track circuits ahead are clear, no problem. So what you tend to find when it comes to signalling failures, the track circuit is part of the signalling system. So actually, if you lose power supply by cutting the cables, maybe an animal chews through them or something gets dropped on them. I'm looking at you, track guys and gals. Happens, people make mistakes. I'm joking. But yeah, so a break in the cables, a failed relay. Again, relays occasionally will fail, but we're talking about thousands and thousands of hours before a relay fails. Also, you may you probably won't recognise that is supposed to be a bulb. In your older signals, you have not one, but two. That is a really bad drawing. Two filaments in your bulb. So if you have a light bulb in your house, it has a filament in it, and after 8,000 hours, your filament breaks and your light goes out. That doesn't happen in signals. Even, I don't know how long I've had double filaments in them, but certainly since I was an apprentice, and much longer than that, so a while. If a light goes out in your signal, if a filament breaks in your signal, you actually have a secondary filament in the light bulb that's inside the signal head. And not only that, but even in the not most modern systems, you will have reporting back to your signal box or back somewhere where maintainers can get to that will actually tell you that your main filament has burst, your main filament is broken. Okay, so there's a system of checking if both your filaments are intact, or if you're not checking they're both intact, but it will tell you if the first one has gone, which gives you extra 1,000 hours to go and replace this bulb with another one with two filaments in it while the backup filament is still working. So even old bulb signals tend not to, you don't even losing a bulb isn't even a thing that generally causes you a problem. And that's not even to mention how many thousands of hours LED signals are. So most people are familiar with modern LED signals or modern LED traffic lights if you've not driven a train and had a good look at the signals. But loads and loads of signals. I don't know what percentage of signal heads in the UK are LED, but there are tons of them, and they are much more reliable than bulbs. They last for thousands and thousands more hours. So an actual signal going out is not generally, even when you consider the types of failures that can happen in the signal, they're not generally that common a failure. Your track circuit is much more exposed to things like, you know what that is? If you've experienced British summertime, you should know what that is. That's flooding. So, two wheels, rail wheels across your track on the bottom of a train will short out a track circuit. So will a nice spot of flooding. Interestingly, I think the resistance actually goes up when there's ice a little bit. But enough water across your track circuit will short it out, which then means, so if your track circuit is flooded, if I have a signal at this end, okay, so this signal is protected, is staying red because we can't prove that this track circuit is clear because it's full of water, which is a pain in the butt if you're trying to get somewhere, but also if you're on a train approaching this signal, it's actually quite a good thing because it means you're not going to horse into a flooded track at full line speed. So it's actually quite good. Another thing that happens is axle counters. So instead of having track circuits, you have the option to use a thing called an axle counter. It works by generates a magnetic field in the same area where you would have your track circuit feeding into your rails, and what it does is as a wheel passes by the detector head, it changes the flux of the magnetic field, and the axle counter goes, oh, that was probably a real wheel, and it counts how many real wheels pass at this end. So you count in. So you come across here, and if 8 wheels come in here, the axle counter counts to 8, and there's another detector head at the other end, and as the wheels pass in that direction, it'll count 8 wheels and say, okay, 8 went in, 8 went out. The full train has passed through the axle counter section. It's counted the axles, effectively by counting the wheels. Maybe it should have been called a wheel counter. Who knows? Axle counters, unfortunately, again for our viewers in Scotland, I'm going to have to draw this. You won't have seen it all summer. Ever been on holiday and you have your phone in your pocket and you take it out and it's absolutely melting and it doesn't work very well? Unfortunately, axle counters have... So track circuits are, slightly paraphrasing, but almost all electrical. There's no electronics in a track circuit. Unfortunately, axle counters are generally more reliable. They are a bit better. They have less limitations on them. They're not... they won't pick up on flooding, which not necessarily a benefit. But because they have electronics in them, they can be a little bit more temperamental if it gets very hot. Not generally a problem in Scotland. Viewers in the southeast may have experienced signal failures due to hot axle counters. So that's the record put a bit straight about signal failures. The failures of an actual signal are quite rare. Of course, signals, just like our track circuits, have cables in them that lead everything back to the signal box. And yes, you can get damage to your signal cable, same as you can get damage to your track circuit cables. Generally, there's more protection for signal. I'm not going into the details, but there's more protection for signal cables than there are for track circuit cables, just purely by their nature of being out on the track. More things can go wrong with them. Obviously, signal cables only need to get to the signal. Track circuit cables need to get onto the rails, which means sometimes they need to pass over another line. If there was another line on this side, you get the idea. No, really, people did used to pay me to draw things. Generally, I use a computer. So yeah, track circuit cables are exposed to all the elements: heat, water, damage from animals, damage from cable theft. Again, cable theft is quite a big one. So all of these functions might share, at some point will share a cable going back to the signal box. Also power supply. These are the bigger cables are the ones that people tend to steal. So power supply cables tend to be chunkier. So if someone's going to steal a power supply cable, the signaling won't work. The tracks are still there, but generally, if you go to the station, it will say signaling problems due to power loss. It won't say power loss. It was trying to. I guess they're trying to express to you can't jump on the train because and again that's why you can't just whiz up and down the railway if there's no power. There's power in the overhead lines. If it's an overhead line place, there's power in the train, obviously. But if there's no power for the signalling, then it's not safe for you to be whizzing up and down at full line speed. So that's it. Cable theft is actually a really big one, and it's actually, if this cable's damaged, then an S&T man or woman can come out and fix it. And jig time, I'll say jig time, because they're good. I know, because I've done it. I've been there. But if it's a power supply, much harder to fix, and it affects everything. A track circuit failure of just one track circuit, depending on where you are, not a massive problem. But yeah, so there you go. Cable theft, killing the power to all your signalling, or flooding of a track circuit, overheating of an axle counter. Those are your actual common signal failures, and yes, they are part of the signalling system. I'm not trying to blame track for track circuit failures. 100%. That is a signalling problem, but signalling failures, signals tend not to fail. So I did stop the tape so that I could clean the board and make a new drawing. But I think we'll just go with camera trickery for this one and put a picture up instead of you trying to figure out what the hell I've scribbled up. So one of the other really big things that will cause havoc on your network is points and switches, or switches and crossings. Now, if you go in the front of a train, you will find there is no steering wheel, because to get trains to change direction, we use these. Now, in the UK, since roughly 1892, yes, you heard me right, 1892, it is a requirement that these are locked in place before you put passengers over them. So this is quite a modern set that I've got in the picture. So this is all electrically detected and it's electrically moved as well. So you've got the electrical proving that the blades are in the right place, and you've also got the physical movement of the machine. So you can probably imagine right away that is much more complicated even than a track circuit, especially because you've got the movement, so you have to physically move your point somehow. You also, as well as moving the very front, you can move the back. The longer these come in different, just like road turnings, if you like, these come in different lengths of curvature. Different lengths of curvature, doesn't make sense. Different curvatures, different angles. So some of them are longer and faster, some of them are shorter and tighter turns. The longer ones require you to physically move the back end of the bits of the middle. These are called the switch blades. These are the moving parts of the switch blades. So your switch blade, the longer your switches are, the more movement you need up the back. So you might be moving 3 or 4 different bits of the switch. So you've got either motors or hydraulic action in them. Again, even the hydraulic ones have a motor to pump the hydraulic fluid, and then you've got all the cables, same as you do for a track circuit. You've got to get the cables right into the rails, and that just leaves you a little bit more exposed to potential failures from cable faults. As I said, you've got motorized parts, you've got the detection. So if all of that is not working perfectly, then your points are failed. Again, if you have a signal before your set of points and your points aren't 100%, everything's all in order, then you're not going to be able to get your signal off. So again, that is going to come into signaling failure, or signal failures as described here. It's not actually a failure of a signal. Signals don't just break. It's just that if you can't prove that your points are 100% tip top, then you must not let trains pass over.